The purpose of this video is to help you better understand how the various gear train components in a 6L80 operate. Of course, the main reactive element is this compound planetary or Ravenel gear set. It's quite an amazing engineering feat. First of all, there is a front planetary gear set. It is a simple planetary gear set. It's not a compound one like that one over there. It's just got one sun, one set of planets, one ring gear. But this impacts the first 5 gears and reverse, okay? So this is critical to the final ratio of what happens with all of the gears except 6th, okay? So to begin with, this turbine shaft, the input shaft, houses the 4-5-6 clutch, okay? And we're going to show you a ratio here in a minute, how this planet is driving the 3-5R 1, 2, 3, 4 clutch drum at all times. This planet splines or is connected to this drum, okay? And, well, let's begin. I'll go ahead and I'm going to put this planet down inside here, okay? And, of course, the input shaft will be driving the ring gear, all right? This sun gear is always held in place. And so the reaction, or the output is, the outcome, is whenever the ring gear, well, the outcome is really, whenever the carrier is the output of what's going on, it's gear reduction. So the ring gear is the input, the sun gear is the held member, because this sun gear never rotates. It is always in mesh and is held by the bell housing pump, transmission pump assembly. So it never rotates, all right? We're going to drop in that gear. We're going to drop the 1, 2, 3, 4, 3-5R clutch drum assembly onto that carrier. And there it goes, there it goes. It now just connected. Let's now reach in with the bell housing and that stub, or that shaft of the sun gear to hold that sun in place. Let's line up my white marks. So here's my input, and here is my 3-5R 1, 2, 3, 4 clutch drum. All right, and I'm going to use the turbine to drive the turbine shaft from the torque converter. Okay, just kind of fun. I got to hold the bell housing in place, which will hold that sun gear in place. And as I turn this turbine, it's going to turn the drive or input shaft or the turbine shaft. And we'll watch the ratio or the difference, the relationship of what that front planetary gear set, how it impacts this clutch drum. Here we go. So I've just turned the drive shaft, the input shaft, okay, 1 revolution. We've not seen this turn 1 revolution yet. There it is. This just made 1 complete revolution. But the input shaft had to rotate 1.53 times. And the white mark for this is about 180 degrees away. So there's our 1.53 to 1 ratio. That planet gear creates a ratio between the input and its output, of course, is this clutch drum. Okay? Now that ratio is going to have impact on everything that occurs with the 1, 2, 3, 4, and 5 gear ranges and reverse. Because this is clutch 1, 2, 3, 4, and this is 3, 5R. And something interesting happens with 3rd gear, and we'll get to that. Because both clutches are applied with 3rd gear. All right. Here's the white mark down here that we'll be referring a lot to. And of course, again, this is the compound, double-acting Ravenel planetary gear set. Now, first gear, the first gear drive ratio is 4.03 to 1. Okay, in other words, this input shaft has to turn 4 times to make this turn the drive line for 1 time, right? But there's one problem. It's not going to be that simple. Remember the 1.5 ratio that this planetary gear, the primary, the simple planetary gear, has influence on the 1, 2, 3, 4, the 3, 5R drum assembly, clutch drum assembly. Because of that, well, I'll show what we're going to do. I'm going to reach in with this first drive shell, which is going to turn the lower sun gear of this compound planetary gear set. Okay. There we go. And there's a white mark, and there's a white mark, and they're pretty close. I guess they're not perfectly lined up. There we go. I got them lined up good now. First gear, the 1, 3, 5, the 1, 2, 3, 4 clutch is applied, which is going to turn or drive this. And the carrier of this compound planetary gear set is held in place by the low reverse clutch at the back, on the back side of this center support. And this center support, is lugged or, fastened to the transmission case. So this doesn't rotate. Anytime these clutches are applied, they break or they hold the device. Okay? So, but the 3.5R and the 1, 2, 3, 4 are always driving type clutches. So here we go. I'm going to hold this in place, and because I have a 1.5 ratio created by the drive shaft, I've got to take the 4.03, divide it by 1.53, and what I come up with is 2.63. In other words, I've got to turn this 2.63 times to get this to turn once. And again, that's because of what's happening with this front planetary gear and that drive ratio. Okay? So here we go. I'm going to hold the carrier like the low reverse clutch would, okay, while I turn the small sun gear, the small drive shell. Here we go. So, there's 1 revolution, 2, and the white mark is coming up, and there it is, that's 1 revolution, and the white mark ended up over here, about right here. So it had to go 2 and 0.6 of a revolution to turn that once. Okay, and again, that's because of what's going on with this planetary gear set, with this clutch assembly, and how it turns this drive shell. Let's go to second gear. The overall ratio for second gear is 2.63 to 1. So the input shaft would turn 2.63 times to turn this once. But once again, there's a 1.53 ratio going on between this and this. Okay. So second gear is achieved by, I've got to have both drive shells in place, because second gear, to achieve it, this shell has to be held by the 2/6 clutch. So it's applied and it holds this. So we're going to reach in and hold the top or the large sun gear while we reach in and turn the lower or small sun gear. And if I can get that to fall in a little smoother, that'll work. Here's a white mark. Here's my white mark. Second gear. I take the 2.63 3:6 ratio divided by the 1.53 input ratio, that combination, again from that. And what it ends up being is 2.36 divided by 1.53 gives me 1.54. So in other words, I turn this 1.54 times to turn this once. Here we go. I hold this because the top sun gear, the large sun gear, while I turn the bottom one. So there's one revolution right there. Haven't seen the white mark yet. And the white mark just showed up. There it is. And my other white mark is over here, just slightly past, 108 degrees. So therefore, 1.54 of a turns gives me one output. That's second gear. Third gear is kind of neat. Third gear is neat because we, in a sense, are, we lock these two together, which locks this planetary compound. The two sun gears are locked, and therefore it turns this whole hunk of metal, one mass, okay? Everything turns together. It's kind of like a direct drive. However, it's not, in a sense, really direct drive, because the drum that's turning both of these drive shells, once again, is at a 1.53 to 1 ratio to this input shaft. So there you have it. The output ratio of third gear is 1.53, because ultimately this is the planetary gear set that impacts what's going on in third gear, because this again is all held together. Because both clutches are applied, therefore both clutches are going to, they're tied or hooked up to that drum, and they're going to turn everything together as one big unit. And sure enough, it's just like a 1-to-1 ratio. Again, the third gear ratio is determined by the front planetary gear set. Fourth and fifth gear, I can't really show you. Let's do sixth gear and reverse. Okay, we'll do sixth gear and reverse, because I got to expose this compound gear set to show you fourth and fifth. So, sixth gear, kind of fun. Sixth gear, I don't need the 1, 2, 3, 4 drive shell anymore. I don't need the 3.5R. Well, I guess I do need the 3.5R, because we're going to use the 2.6 segment of it. Okay, the 2.6 clutch will apply and hold this shell in place. But we will now use the direct shell. So this being held, and this direct shaft, it comes in and directly hooks up to the carrier. Okay, it hooks up to the carrier. So sixth gear is achieved by holding the top sun gear in place and just simply driving this carrier. Whenever a carrier is the driving member, the result is overdrive. Whenever the carrier is the output member, like we demonstrated earlier, the result is underdrive. And whenever we lock two members of a planetary gear set together, the result is direct drive. And of course, we'll get to reverse, where we hold the planet. Okay, sixth gear. The final ratio, the overall ratio is 0.67 to 1. In other words, I'm going to turn, watch this. I'm going to hold that sun gear with my finger. And I got a white mark on this. Okay, let's get this around. So drop in the direct shaft. I only need to turn this 0.67 to make this turn once. And the reason we don't have to worry about any of the drive ratios here is because the 4, 5, 6 clutch is now involved. And it's just going to turn this 1-to-1, direct. Here we go. I got to hold the top sun gear so I can turn this planet. Okay? And here comes the bottom. There he is. There's the white mark. And this white mark went around over to here, about 2/3 or 0.67 of a turn. There's my 6th gear. Reverse. Well, I better use the 3.5R drive shell. The 3.5R clutch is what turns this. But the low reverse clutch, okay, which is locked to this carrier here, it holds. So with this carrier held and with my 3.5R, that's the drive member, the output turns opposite. Again, the carrier's being held. Okay, that's reverse. Hold the carrier, turn the 3.5R clutch, or apply the 3.5R clutch to turn the large sun shell, the large gear, the large sun gear, that is. Okay, that's gear ranges 1, 2, 3, 6 in reverse. To show and expose what's going on for 4th and 5th gear, I'm going to take off the output shaft ring gear housing. We'll put the carrier here now. We can now that we've exposed these planets of the compound planetary gear set. What we do from here on won't be quite the same as what we've done here just in the last few minutes. 4th gear, the overall ratio that would turn the output shaft is 1.15. So the input shaft would have to turn 1.15 times to turn this once. Can't really demonstrate that, but I can show you how it is achieved. I need the 1, 2, 3, 4 drive shell to turn the bottom set of planets. I also need the direct shaft because that has the 4, 5, 6 clutch directly connecting the input shaft to it, right? If I was to get those all to fall into place and mesh like that. All right. So the direct shaft comes in and it turns, okay, if you can see that, it turns the carrier. Whenever the carrier is the input, the driving member, the result is basically overdrive, except in this case, this clutch, the 1, 2, 3, 4 clutch is applied, turning this set of gears as well. So it won't be quite a true overdrive until we get to 5th gear. All right, so the direct shaft is turning the carrier while the shell, because it's turning slower than the direct shaft, the 1 to 1.153 ratio. So I'm turning the carrier while I'm also moving those gears, and the result is how it impacts this ring gear to develop a 1.15 overall ratio 4th gear. Kind of a neat concept. We've got a compound thing going on. We're turning the carrier while we're also turning these other gears basically slower than we do the carrier. 5th gear, not a lot of difference. 5th gear, we're going to turn the other sun. We're still using the direct shaft, okay, coming directly from the input shaft. 5th gear, the overall final ratio, the outcome is 0.85 to 1 ratio. So I'm going to turn the direct shaft still, which is turning the carrier, but now we're going to be spinning these other planets and how they mesh with that ring gear to influence, or I should say, create 0.85. So I got to turn this 0.85 of a revolution, the direct shaft, 0.85, to get 1 revolution out of the output shaft. Okay? So, again, I'm turning the carrier, which is an output reaction, and I'm turning these gears as well, but at a slower rate than I am the carrier. Almost. It's just they're turning slower. But the result is an overdrive type ratio. And of course, again, to get the sixth gear, remember, we simply held the sun gear totally in place and just simply turned the carrier and those gears, these planets, spin this output even faster, the output shaft even faster. So there you have it. There are all the gear train components, the clutches, the drive shells, and how this front planetary gear set and this rear compound planetary gear set work together to create all 6 of the forward ranges and reverse of a 6L80 transmission. Here is one technical piece of information in regard to installing the ring gear. The smoothest side goes towards the snap ring. One side is stepped, and the snap ring won't go in all the way. So you need the smoothest side, again, toward where the snap ring will go. So let's put this together again. Let's see if the snap ring goes in correctly now.
The smooth side of this ring gear goes towards the snap ring.
Yes. Okay. Rear planet, output shaft speed assembly.